last time we had class, which was last Thursday, we had Mr. LeBaron come here and give a presentation. You'll want to know that today we're going to have a quiz, and there will be some questions on that quiz. Most of the questions will be this, but there will be a question or two about what he talked about. So if you weren't here, that sucks for you. Okay. If you're a good BSer, you might get some points. We'll have to see. So anyway, Okay. All you guys that had doctor's appointments on Thursday last week. It doesn't matter. Okay. So anyway, before we do that though, you guys, I'm going to go over lots of problems right here. So if you want to know how to do these, we're going to have lots of problems. Also, we will be having a test on Friday on this stuff. I told you, I think, last time that we'd do it on Wednesday. But what I'm going to do, the reason I'm delaying it till then is because how many of you are going to take the Trig Star test, by the way? By raise a hand, who's taking the Trig Star test? I'm not going to let we're not going to let the calculus kids take it. So only pre-calculus. You have a chance to win $200, $100, or $50. So raise it. Casslin's not going to take it. Jared's not going to take it. Sarah's not going to take it. Those are the three that won it last year. If you're going to take it, please raise your hand. I need to know. Keep your hand up. Hi. Okay. So you know, those of you who are taking it, you'll be taking it during this period on Friday. However, you'll have to make up your test at some point because we're going to take a test in here on that day, okay? So you might want to come in and take, you guys, I'd appreciate if you'd listen when I'm talking because you might miss some important information. You'll probably need to come in and take it early just so you don't forget the stuff, okay? Let me just tell you this as well. The test is going to be on lesson 7-1, 7-2, and 7-5. If you remember right, 7-1 is when I introduced you to the fundamental identities, and we had a couple problems that we worked in there. I will review some of those on Wednesday. 7-2 was proving those identities or establishing those identities or showing that they were true, where we had to show one side was equal to the other. Okay, and we're going to go over more of those. You all got that piece of paper that I handed out, right? That had those 8, or I think there were 6 problems on each side that had those identities. It looked like this. If I can't remember when I handed it out in this class. So who did not get this one? Okay, Tasha and Sarah. Did you not get it? Pass one down, Tasha. I can't remember when I gave this out. I probably gave it out last Tuesday, I think. Okay. Now, I will go over several problems on this. That will help you review for 7-2. And then 7-5, today is the review for 7-5. So if you want to know how to do 7-5, today is the day, okay? I will be going over lots of problems. So starting right here. I am going to start with these problems right here. There was a one, but I think last year when I wrote this down, I forgot to put a squared in there somewhere, and so it wasn't working out very well. So we won't worry about that one. Okay, go into number 2. Most problems that you're going to see, the harder problems you're going to see are like these 2 right here. And they're really not that hard if you learn to recognize a little trick. I know you guys don't think of these things. That's why we practice them a lot, so that you'll start recognizing them. That right here, does anybody know what we're going to do on this one? That's exactly right. We're going to factor out a tangent. You'll notice that there are 2 terms. That's one term, and that's the other term. Terms are separated by plus or minus signs. So in this one right here, we'll notice that there's something common to those two terms. What is common to both terms? The tangent of x. So we are going to factor out a tangent of x. Well, when I factor out a tangent of x, what does that leave me with inside the parentheses? Sine of x root 2 over 2, right? Because I took a tangent away from there that left me with the sine, took the tangent out there, left me with the square root of 2 over 2. Okay, now, we also, and so that's one of the things you're going to look for. If there's no squareds or anything, or even if there are squareds, you might want to look to see if there's anything common to every single term. And if there's something common to every single term, you're probably going to want to factor that out. Then you're going to look for a different method. And we'll go over some other problems and look for different methods. Okay, this one right here. Now, once you get it down to two factors being times together that are equal to 0, what can you do from there? Well, you can set each factor equal to 0. And then you'll be able to solve those each. Now, this one's already solved, tangent of x equals 0. What do I need to do to get sine of x by itself right here? Okay, add square root of 2 over 2 to each side, and that's what you get. Are we done at that point? No, we're not done at that point. We need to find the angles. Now, everybody get out your table of values. You're going to be able to use this on the quiz today as well. Tangent of what angle is 0? Between 0 and 360. 0 degrees? Where else? And 180 degrees. You guys want to do this? You want to do this one in degrees or radians? We'll do this one in degrees. We'll do the next one in radians. So one of our answers is x equals 0 degrees. The other one is 180 degrees, right? Okay, and both of them plus 360k. Why 360k? Yeah, because each time you add 360, you take it to a complementary angle. For example, for those of you who don't understand, like if my answer was 30 degrees right here, every time I add 360, I land right there again. And every time I land right there, it's going to have a sine of 1/2 or a cosine of square root of 3 over 2. It'll be the same every time. And so that represents all the values because there's an infinite number of answers to this question. All we did is listed 0 and 180, which are the ones between 0 and 360. And then we add 360k to represent all of them, okay? All right, sine of x equals square root of 2 over 2. Where does that happen? 45 degrees, where else? Huh? 130, yeah, 135, you're right. Plus 360k on both of them, right? Okay, so that's how we would get the answers to problem 2. So number 2, you're going to see somewhere you have to factor out a common factor. So keep that one in mind. I would put a star by it and say, let's study this one. Make sure I know how to factor out a common factor. All right, let's go to problem number 3 right here. This is the other one that's kind of difficult. But once you get the hang of it, it's not too bad. You just got to learn to recognize it. What does this one look like? As a cosine squared. Let's do this. Let's get everything to one side. I'm going to rewrite this as cosine squared of x. I'm going to get this one to the left side. So what am I going to have? Plus cosine of x. I'm going to get this one to the other side. So what am I going to have? Minus 2 equals 0. Say that again, Sydney. It looks quadratic, and that's what it is. We have to do this one kind of like a quadratic. Okay, so think of this one as wherever there's a cosine as just x squared. As x. Do you guys know how to factor that trinomial that's on the left side? What two numbers can I times together and get -2, add together and get 1? -1 and +2, right? Except for x is really cosine of x, right? So I'm going to have a cosine of x and a cosine of x. Since those are the same, it doesn't matter where the positive 2 and the negative 1 end up. Because I wanted to find the two numbers you times together and get negative 2, so when you add them together, you get positive 1, which is the middle term, positive 1x. Okay. I have a factor times a factor equals to 0. What does that allow me to do? Set them both equal to 0 and solve them. Solve this one. What am I going to do to both sides of this one? I'm going to minus 2. What am I going to do to both sides of this one? Add 1. Cosine of what angle is a negative 2? Okay, Jared says no angle. What do you think? Emily agrees. What do you think? Why? Why do you guys say that? Do you guys remember all answers to cosines and sines have to be between 1 and negative 1? Remember that? So guess what? Anytime you get something like that, a sine or a cosine that's more than 1 or less than negative 1, then you know that there's no answer. So that one cancels out. But what about cosine of what angle is 1? 0. And 360 is back to coterminal angle is 0, so we really don't technically need to write that one. What? Well, 0 plus 2 pi k, because I told you we're going to do this one in radians. 2 pi is once around a circle in radians. Does everybody understand that? So 0 radians plus 2 pi times k, which means it can go around whatever many times we need it to. Cosine squared of x. Oh, and then you factor out a greatest common factor, or what? Yeah, then we just say it's cosine times Well, I'm not sure you can even do it that way, because if I'm understanding right, let me just see. You guys went cosine squared of x plus cosine of x is equal to 2, and then you factor out a cosine here. Well, the only time you can set two factors equal to 0 is when that's 0 over there, and that's a 2. So technically, you couldn't even do it that way. Probably just by coincidence. It wouldn't work every time. Really? Well, cosine of x equals 2 and cosine of x plus 1 equals 2, and you minus 1 and got 1. Oh, that is interesting. I don't know. I don't think that would work every time. I'm pretty sure it wouldn't, but we could. Yeah. Yeah, that would be coincidence that it happened that way. So don't do it that way. Okay, any questions on that one? Okay, before we have the quiz, I'm going to go over problems on your assignment. Emily, 22. What does 22 say, Emily? And how does it want me to give the answers? Yes. Okay. Hurry back so you don't miss some good stuff, guys. You're not going? All right. Tell them that Chandler doesn't want to come for some reason. Yeah. All right. Principal values. That's what I want to talk about. Hey, guys. Principal values are like the inverse. Do you remember when we were solving for sine inverse the answers had to be between negative 90 degrees and positive 90 degrees. So first and fourth quadrants. Do you remember that? And tangents the same way, first and fourth quadrants. And then cosine had to be between 0 and 180 degrees. So sines will have to be between negative 90 and positive 90. Same with tangents. And cosines have to be between 0 and 180. So that's all you have to do is name the principal values. So let's do this problem right here. Notice that we have sines and cosines. You see that? And I would think that since one of these is squared and one of them is not squared, that I would probably, if they were both squared, I could probably look at using a Pythagorean identity to replace the whole thing. But as it is, what I'm going to do is want to change everything to sines or everything to cosines. But I'm looking at this cosine squared. That one would be easy to change to sines. What could I replace cosine squared of x with? 1 minus the sine squared of x. That's exactly right. So sine of x equals 1 plus 1 minus the sine squared of x. Okay, and now everything is in terms of sines. And notice that one of them's squared and one of them's not. So what kind of an equation is this going to turn into? Quadratic again. Right? That's exactly right. So right here, I am going to get everything to one side, and I always like my squared term to be positive. So I'm going to get it to the left side. So I'm going to add a sine squared to both sides. That's going to leave me a sine squared of x over here. And if I add sine squared of x over here, that's going to be 0, right? I'm also, 1 plus 1 is 2, so I'm going to get that to the other side. That's going to be a minus 2, but I'm going to have the sine of x first. Plus 2 equals 0. Oh, yeah, it would be minus 2. Okay, it would be minus 2 because 1 plus 1 is positive 2. If you minus 2 from both sides, it would be minus 2. Okay, now I have a quadratic equation, right? What's this one going to factor to be? What two things can I times together and get sine squared of x? Sine of x and sine of x. So sine times sine is sine squared. So I know my first terms in each of the factors is sine. I can look over here. What two numbers can I times together and get negative 2? 1 and negative 2. Now, since these two are both the same, it doesn't really matter which one's which. Oh, but it does matter. One of them might be, we might want to change it around. We have a 1, a negative 2, or a negative 1 and a positive 2. Which one do we want? Yeah, we want positive 2. Yeah, this one's just like the bell word. Why do we want positive 2 right there? Yeah, negative 1 and 2 added together is positive 1. And we are looking for the two numbers we can times together and get negative 2, but add together and get a positive 1 right there, right? Okay, so, all right, so we set it's a factor times a factor equal to 0. What can we do? In this one, it doesn't matter because they're both sine x. I could have put the plus 2 over there and minus 1 here. It doesn't matter. It matters if there's like a 2 in front of that or a 3 in front of the sign or something like that. We'll do one like that in a little bit here. I'm pretty sure you'll ask me on that one. Okay, so I can set each factor equal to 0, right? Because a factor times a factor equals 0. That means each factor can be set equal to 0, and we can have a solution here. Okay, add 1 to both sides of this one. So we have sine of x equals 1 minus 2 from both sides of this one, and I get sine of x equals negative 2. Right off the bat, what do you see? We can just throw that one out, right? Because there's no way you can have an answer be greater than positive 1 or less than negative 1. And negative 2 fits in that category. Okay, so sine of what angle is 1, you guys? 90 degrees. And so my answer is x equals 90 degrees. That's the only principal value. So that's my answer. Okay? All right, 38. Yes. If it's radians. Did it say whether it was radians or degrees? Where's it? So what number did we just do? 22. Yeah. So you'd want to do it in degrees. The other problems, this one's in degrees too. Yeah, well, let's see. This one has to be in radians. And this one, this one doesn't say, so you could be either radians or degrees, okay? That section. Okay. What number was that again? 38? What does it say, Jerry? See if I wrote that down right. All right. Raise your hand if you see something that we could do to help us out with this problem. All right. Maybe you don't have to raise your hand, but how many of you know what to do? Let me put it that way. How many of you notice there's a cosine in each term? Okay. Yeah. If there's a common factor like this one, there's at least one cosine in each term. We're going to factor out a cosine. A lot of you guys are saying that. So factor out a cosine. What's that going to leave me with? Tangent of x minus 2 cosine of x. You know what? I actually think there's a better way to do this one. Huh? I know, that's why I said there's a better way to do this. Right when I started writing this down, I could see. Hey, does anybody see anything else we could do with this one? Yes, you are. In fact, not only are you allowed, you're encouraged. What else could we do? Could we simplify this a little bit? What could we do? Yeah, if I change tangent to sine over cosine, guess what happens? Cosines cancel out, right? Now, here's the problem, though. Now I have a sine and a cosine. Megan said it right there. She noticed we have a cosine squared again. We already used this trick once before. We can replace it with 1 minus the sine squared, right? So I have the sine of x, that sine of x right there, minus 2 times, and we're going to replace cosine squared with 1 minus the sine squared of x equals negative 1. Got it? We replaced that cosine squared with 1 minus the sine squared. So why did we do that? Why would we do that? Everything is in sines, right? Okay. Yeah, that's the next thing we need to do. We need to distribute the two. So we have sine of x minus what? 2, then what? Plus 2 sine squared of x. And I'm also going to add the 1 to both sides. So 1 equals 0, right? This is kind of looking quadratic, isn't it? Should we put it in descending order? So what's going to be first? 2 sine squared of x plus sine of x minus 1, because negative 2 plus 1 is negative 1, equals 0. Now, this one matters how we factor, because the first term is going to be a little bit different here. Say that again. Well, you have a 2 over here. Don't forget that. So when you factor this, what two numbers can you times together to get 2 sine squared of x? 2 sine and sine. So one of yours is going to be 2 sine of x, and one of them is going to be sine of x. Now we know there's only one way to go two numbers times together and get -1. What is that? 1 and -1. But it does matter where the 1 and -1 goes, doesn't it? Does anybody know which way? Yeah, the -1 would go here. Why? Yeah. If you guys, in the FOIL, of course we know that 2 sine times sine is 2 sine squared. We did that. -1 times 1 is -1. But for the middle term, we want it to be a positive sine of x. You get that by timesing those two terms together and those two terms together and adding them together. Well, if I add 2 sine of x times a positive 1, I get a positive 2 sine of x. And -1 times sine of x is negative sine of x. And when I add those together, I get a positive sine of x, which I want. If I was to reverse those signs around, I would have had a negative sine of x, right? And I wanted a positive sine of x. So, okay. So, I have a factor times a factor equals 0. So what can I do? Set each factor equal to 0. Okay? Solve that for sine of x. What would I do to solve this for sine of x? Add a 1 and divide by 2. And -1 on that one. Okay. I think you guys can look them up from there. By the way, how did it say to state the answer on this one? All real values? Doesn't say between two numbers? All real values? And does it say whether it's sine or whether it's degrees or radians? So I'll let you put it in degrees or radians, whichever one you want to do. Okay? Yeah. Oh, yeah, you can. Okay? 26. Look them up. Sine of what angle is 1/2? Look them up on your table of values or look them up on the other. Sine is going to be in the first and fourth quadrant. No, if it's asked for principal values, it's in the first and fourth quadrant. If it just says all real values, you should find anything between 0 and 360, and then you add plus 360k. Okay. Marion, tell me what 26 says. Okay, this one right here is what? What type? Quadratic, isn't it? So, once again, we got to factor it, right? Nice thing about it is everything's written in cosines, right? So it should factor pretty easily. Okay. What are two numbers I can times together and get 2 cosine squared of x? Okay, 2 cosine of x and cosine of x. What are two numbers I can times together and get -2? It's going to either be 2 and -1, right? Or -2 and +1, either way. Which one is it? I think it's going to be positive 2. And do you know where the positive 2 would go? It would go on the second one, wouldn't it? I'm going to show you again. Ready this time? Okay. You ready? All right. Don't talk to anybody when I turn my head and go say, hey, Connor. Okay. Connor, if you know the FOIL method, right? And you times this by that, and then this by that and that, right? To get the first term, you times 2 cosine by cosine, you get 2 cosine squared, right? To get the last term, you times this one by this one to get that one, right? To get the middle terms, you times those two together, and times those two together, and then you add them together, right? You've been doing this since Algebra 1. You've got to know how to do this. Do you want me to write it all out for you? I'm going to do the whole thing. 2 cosine x times cosine of x is 2 cosine squared of x. And 2 cosine of x times 2 is 4 cosine of x. And negative 1 times cosine of x is negative 1 cosine of x. And negative 1 times 2 is a negative 2, right? Okay, so there's my first term. There's my last term. But the 2 middle terms are like terms. You're going to add them together. Well, 4 cosine of x minus cosine of x is positive 3 cosine of x. That's what we had up there, right? And we knew to get that, we had to put the 2 over there because we times the outside together. 2 times 2 is 4 cosine of x, right? And in the middle, negative 1 times cosine is negative 1. And we knew that 4 plus negative 1 made 3. And that's why we knew why the positive 2 went out there. Okay? So I'm going to erase this part because we don't need it. So we have a factor times a factor is equal to 0. What can I do from there? 2 cosine of x minus 1 equals 0. Cosine of x plus 2 equals 0. I'm going to solve this one for cosine of x. What do I do? Add 1, divide by 2, and I get and this one. What's the problem with this one? Yeah, because you can't take the cosine of an angle and get a number greater than 1 or less than negative 1, right? That's outside of it. So cross that one out. So our only answer is cosine of what angle is 0? Wait, where did I get 0 from? Holy cow. 1/2. Thank you. All right. Hey, if you guys get confused, it's probably because I made a mistake. Just ask me. All right. Cosine of what angle is 1/2? 60 degrees? What did this one ask me to give the answers from? Between 0 and 360, so there's one more answer. What is it? What is it? Zero and 360? Okay. Between 0 and 360, so there's my 2 answers there, right? Okay. Thanks, Don. All right. Okay, 31. What does it say? Well, just guessing what it looks like. I'm guessing what? Huh? It's quadratic again, right? And what do we have to do to solve a quadratic? I get everything on the same side. So what do I have to do to get everything on the same side? Add 4 sine of x to both sides. You guys are having trouble with the factoring ones, aren't you? Yeah, you can use the quadratic formula. Negative b plus or minus square root of b squared minus 4ac over 2a. You can use that. You guys want to use a quadratic formula? Or do you want to factor it? Or do you just want to sing the song? Or would you like Tasha and me to sing it together? Tasha, you want to come sing it with me? I think it'd be better if you and Connor sing it together. Huh? I think Marin's going to do it. You know the song? All right. Sorry, I forgot to turn that back on. Factor to be 2 sine of x plus 1 times 2 sine of x plus 1. We only need to do one of the factors. Hey, by the way, on your quiz today, you guys, on your quiz today, several of the problems start like this. Can you do it from here? And I have to say, there's some square roots and stuff in there, but if you just solve it for that, then you got the answer. Divide by 2. Sine of what angle is negative 1/2? What? This one has to be in radians? Between 0 and 2 pi or what? 0 and 2 pi in radians. So what's the answer? 7 pi 6? And 11 pi 6? Has to be in radians. Okay, I'm not going to write it down. You guys got it. Hey, you guys, on the quiz today, I don't even think I put a quadratic one, to tell you the truth. I put one on there, though, where you have the cosine squared of x, and you have to take the square root of both sides. You guys remember how to do that? Remember when you take the square root of both sides, you have plus and minus? So remember that. Like, I'll give you an example. Let's say you had a problem that was down to sine, you simplified it down to sine squared of x equals 1/2, and you got to get sine of x by itself. So what do? You square root both sides, right? Whenever you square root both sides, you have to do plus or minus. Now, the square root of 1 is 1, and the square root of 2, well, that's not a perfect square. So we're going to have to rationalize it. Do you guys remember how to rationalize it? Times the top and bottom by square root of 2. And you're going to get square root of 2 over 2. So, when you look for the answers for this one, there's actually going to be 4 answers. Because it can be positive square root of 2 over 2 or negative square root of 2 over 2. What's the positive ones? Pi force, which is 45 degrees. 3 pi force. 5 pi force. And 7 pi force. Because it can be negative as well. Got it? So just know when you do one like that, you're going to do plus and minus. You got to have 4 answers. And if I told you to find all the values, what would you have to add to this? Plus 2 pi k. Because we put the answer in radians. Okay? All right. Are we ready for the quiz? You can use that on the quiz. Yes? For the principal values? I won't have that on the quiz. Don't worry about it. That's automatically out. But well, I think I tell you on all these. I think they're all between 0 and 180, except for one's all the values. Hey, okay. Everybody, take out a piece of paper. Write quiz 7-5 on it. You listen. And if I don't answer your question, then you can raise your hand and ask one.